So the arrangement into families at least gives some semblance of order, but innumerable whys leap to the fore. So this type of sort of the particle jungle that I presented you with, if you're thinking that, oh my gosh, you just mentioned a lot of particles, electrons, muons, taus, electron, neutrino, muon, neutrino, tau, neutrino, up quark, down quark, strange quark, charm quark, top quark, bottom quark. This is just a ton of particles and a ton of particle names, and they all have different masses. Like, what's really going on? What's the more fundamental, more broader theory of these things that can kind of subsume these particles and their theories? And can we just get to that part, because this is way too many parts. See, some people don't mind that the particles, there's this particle soup of particles, there's this particle jungle of very many particles, but some people do mind because they think that, well, learning about these particles and how very many of them there are, is it really helpful if I don't understand why these particles are a thing, and what's the sort of more broad theory that might explain all of this? So that's sort of, I think, what he's getting to here. Why are there so many fundamental particles, especially when it seems that the great majority of things in the world around us need only electrons, up quarks and down quarks? So that's the other thing too, is that ordinary matter, most of the things that we encounter is just really electrons, up quarks and down quarks, in the sense of that protons and neutrons are up quarks and down quarks combined, and electrons are electrons. That's a fundamental particle, thank goodness. You know, most things, most ordinary matter is just electrons, protons, neutrons. So electrons, up quarks and down quarks. So how come we're finding these other types of particles, and how come that they're not really, they don't seem to be as, you know, common in nature? So why are there 3 families? Why not 1 family or 4 families or any other number? Why do the particles have a seemingly random spread of masses? Why, for instance, does a tau weigh about 20 times as much as the electron? So that is almost over 3,000 times the mass of the electron. Why does the top quark weigh about 40,200 times as much as the up quark? So again, top quark is very much more massive than the up quark. So, you know, electron we see in nature, but this other thing, the tau, is a type of particle also in the same family of leptons as the electron, which seems to be much, much heavier than the electron. Of course, it decays, it's not a very stable particle, etc. But, you know, it's much heavier. Why is that? What is the top quark, which is another type of quark? Why is that so much heavier than the up quark? Did they occur by, these are strange, seemingly random numbers. So these masses, these things that we have found, did they occur by chance, by some divine choice, or is there a comprehensible scientific explanation for these fundamental features of our universe? So it's almost like we're taking, when you consider these different types of particles in the particle jungle that we know of, the electron, muon, tau, the electron, neutrino, muon, neutrino, tau, neutrino, the quarks, all that, it does seem a little bit like we're finding sort of snapshots of nature a little bit randomly. We're making measurements of maybe some things that are sort of in that state. And as we mentioned, some of these particles are not even really stable for that long, etc. So is it that we're kind of like chancing upon them? You know, they're just kind of there and we see them in that state for a bit. And is this sort of some random chance thing, and maybe there's even more particle possibilities that we just haven't found because we haven't chanced upon those or something? You know, once you start to find so many, it begs the question, well, could there be another experiment then that finds another particle or something? And is finding the particles as important as it is to understand, well, what's really going on? What's the underlying insight into all of this, which would explain all of the things, all of the particles, all of the everything, without having to go into each one specifically.